When we solve quadratics by factoring, remember, factoring is when we find two things that multiply together to give us a polynomial, or things that we can divide a polynomial by. So we have other videos that can help you solve by factoring if you need to learn a little more practice with the factoring portion of this. When we solve by factoring, we're using something called the zero product property. The zero product property says that if I have two things that multiply together to give you 0, so if 4 times a equals 0, what does that mean? Well, we know how to solve this equation, and if we divide both sides by 4, we notice what you already expected most likely, that a is going to equal 0. So if we're going to multiply something by something and get a 0, then one of those two values has to be 0. So as you may expect in the second equation, a times b equals 0. If a times b equals 0, then either a equals 0 or b equals 0. In the third equation, if a times a minus 2 equals 0, think about it. If a equals 0, then I'll have 0 times 0 minus 2, which is 0 times negative 2. So a could equal 0. But on the other hand, if a was equal to positive 2, 2 minus 2 is equal to 0. So I would have 2 times 0, which equals 0. So a could equal 2 also. So there's two possible values for a in this situation. And finally, in this fourth situation, which is what we'll see most of in the examples that follow, it's a little bit more complicated, but once you've done a little bit of work, you'll notice that x could be negative b divided by a, or x could be negative d divided by c. So to find each of those, it's a little bit easier for us if we set each of these factors equal to 0 and then solve from there. So that's what I recommend that you do on these problems. Let's try a few. In this first one, notice that this is already factored, so it's in what we call factored form, not in standard form. And if we know that 2x plus 3 times x plus 1 is equal to 0, when we multiply these two things together, one of them must be 0 for this to be true. So what I do is I take each of the factors and set them equal to 0 to form two smaller equations. Each of these two equations will have a solution to it, and that's how we get the two solutions that we need for a quadratic equation. Now, it may not look like this was originally a quadratic equation, but if you were to multiply those two binomials together, you'd notice that you get a quadratic trinomial. So we do have a degree of 2. Now, when we go through and solve each of these by using the order of operations in reverse, we get that 2x equals negative 3. And then if we divide both sides by 2, we find that one solution for x is negative 3 halves. And if we were to substitute negative 3 halves in for x in both of these factors, when we multiply those two factors together, we would get 0, because 2 times negative 3 halves is negative 3, and negative 3 plus 3 is 0. In the other equation, all I have to do to solve for x is subtract 1 from both sides, because 1 take away 1 is 0. So I would get x equals negative 1. When I substitute negative 1 into the equations where x is, the second factor will be equal to 0, because negative 1 plus 1 is equal to 0. So my two solutions for this equation are negative 3 halves and negative 1. But what if the problem isn't already factored? For instance, in this situation, I know that negative x squared plus 9x equals 0, but I don't know what can multiply together to equal 0, which means I can't use the zero product property on this until I know what I can multiply together to give me negative x squared plus 9x. Now this is a binomial, and in order to factor a binomial, the first thing I want to look for is a GCF. And if you notice, each of these terms in this binomial contains an x. So I could use x as my GCF. I could also use negative x as my GCF, because you can divide by -1 anytime you want to. So I'm going to use negative x as my GCF just because that's a little bit more challenging and it might help you a little bit more later. If I divide both of these terms by negative x squared divided by negative x is positive x, and 9x divided by negative x is -9. So now I know what multiplies together to give me 0, and also multiplies together to give me negative x squared plus 9x. So I'm going to take each of these factors and set them equal to 0, because if either of these factors is 0, the entire equation will be equal to 0, and that's what I want to find. What makes this equation equal 0? In this first equation, notice that the coefficient on the x is -1. To undo the multiplication, I divide both sides by -1, and 0 divided by anything is just 0. So one solution for this equation is 0, because if I substitute 0 into the first factor, I get 0 for that factor, and 0 times anything will give me 0. In the second equation to solve, I must add 9 to both sides. So that'll give me x equals 9 for my other solution. If I substitute 9 into the second factor, 9 minus 9 is 0, and 0 times anything gives me 0. So I have my two solutions for number 7. In number 8, this is a quadratic trinomial, and in order to factor a quadratic trinomial, I use grouping. And I keep the first and last terms exactly as they are, multiply the first and last terms together to get -28a squared, and I need to find two values that multiply to give me -28a squared, but at the same time add together to give me the middle term, because I'm going to be replacing the -3a with two terms that combine to equal -3a. And if you think about that for a second, you'll determine that -7a and +4a will add together to give you -3a, but also multiply together to give you -28a. So we factor by grouping, and we determine that a plus 4 times a minus 7 equals 0. So we set each of those factors equal to 0, and we solve each of them. So I get a equals -4 for one of my solutions, and for the other solution, if a minus 7 equals 0, then a must be 7. So that's two solutions for number 8. In this problem, notice that it's not in standard form yet. I need a 0 on one side in order to use the zero product property. So I'm going to add the 8x to both sides. It's not like terms with anything on the left-hand side, so I'm just going to rewrite the problem in standard form before moving forward. Once it's in standard form, don't forget to check for a GCF. In this problem, each term can be divided by 2. And once I've divided each term by 2, it's going to make it easier for me to factor. In this problem, that's now inside of my parentheses, I'm going to be multiplying to get a negative or a positive 4x squared, and adding to get a 4x. As you know, 2x times 2x gives us 4x squared, and 2x plus 2x gives us 4x. So I'm going to divide this middle term up into two terms that are equal to it, and leave the last term and the first term in the parentheses exactly as they are. We're not going to forget about the GCF though. It's going to follow us throughout this problem. So now I'm going to go into these parentheses and factor by grouping. Here I have a GCF of x, and here I have a GCF of 2. and the GCF follows us. Now within the parentheses, I can continue to factor this by using the inside factor of each of the terms and the GCFs of each of the terms. Now, notice that I had the same factor twice inside the parentheses. And one thing that I've forgotten to write here is equals 0. We can't forget that we're solving an equation, so we need to come up with a value for x. So I'm going to take each of my factors, 2, and set it equal to 0. Then x plus 2, and set it equal to 0. And x plus 2 again, and set it equal to 0. Now notice that we have the same factor twice, so as you will expect, we're going to get x equals negative 2 twice. That indicates that on the graph for this quadratic, the parabola would have a vertex at x equals negative 2. When I look at my pink equation here, 2 equals 0 is an equation that has no solution. So we still only have 2 solutions to this problem. It's negative 2 with a multiplicity of 2. Finally, we need to solve a quadratic that has a leading coefficient that is not equal to 1. And again, if you're still needing help with factoring, please watch the other video on factoring by grouping. Here we're going to multiply the beginning term times the last term, and we get negative 120k squared that we're multiplying for. And we're going to add to get the middle term, which is 19k. Well, this takes a little bit more thought because it's a rather large number, but after that thought, you'll arrive at 24k times negative 5k. Add together to give you 19k and multiply together to give you negative 120k. So we're going to rewrite 19k as 24k minus 5k, and once again leave the beginning and the end terms exactly the same as they are. Now, is there a GCF for this problem that we didn't find yet? If you look closely, you'll notice that there's no GCF for all of the terms, but there are GCFs for the first group, in this case 3k, and for the second group, which in this case, because there's a negative between them, is negative 5, and when we divide both terms by negative 5, we get k plus 8. Now to continue, the GCF for these two terms now is k plus 8, and the GCFs that we took out originally are 3k minus 5. So I have my two factors, which I now need to set equal to 0, and solve. So I get k equals negative 8 as one of my solutions, and I get 3k minus 5 equals 0 for another equation. If I add the 5 and divide by 3, I get k equals 5/3 for my other solution to this quadratic equation. So for a final reminder, when the problem asks you to find solutions, that means to solve. And we need to find the values of x that make the equation true. So don't just factor like we've done in these problems. Also find those values of x.